Hello everyone, in this video we'll be solving problem 3184, count pairs that form a complete day, part 1. The problem statement is, we are given an array hours that represents the time in hours. We need to return an integer denoting the number of pairs that we can make using I and j that forms a complete day. The sum is multiple of 24. In example number 1, there are two possible combinations one can make. One is using these two 12s, which will give us the total of 24, and the other is these two 24s, giving us the total of 48, and both are multiple of 24s. In example number 2, possible combinations we can make are 3, 72 and 48, 48 and 24, and 72 and 44. Hence, the output is 3. The problem statement is very easy to understand. Let's discuss a couple of solutions starting with the basic approach and then think about how we can optimize it. One way to solve this problem is using brute force approach, where we'll run two nested for loops, one inside another. The outer loop will be used to point or get us the number 1, while the inner one will give us number 2. We'll add the two numbers and verify if the sum is a multiple of 24 using mod operation. If the condition is satisfied, we'll increment our counter. Once the for loop is complete, we'll return the count variable as our output. With this solution, our time complexity is O of n square, as we are running multiple nested for loops on the entire input array, while the space complexity is O of 1, as we are only using one variable to record the number of pairs. Because the time complexity is super huge, we cannot use this approach. Let's think about how we can optimize this. When adding two numbers to get the output, if we know any of the two numbers, we can easily calculate the third number. Depending on what values we have, we can either add the two numbers or subtract them. If we try to apply this formula to the problem statement, we are given x and z. X is the element in the array, while z is 24 or multiples of 24. All we need to do is figure out if there is a y element available in the array. Let's use the first input to understand this better. X is 12, y is unknown, and z is 24. The input value in the array could be greater than 24. So first we need to make sure it is less than 24 by applying the mod operation on it. After applying the mod operation, the remainder is still 12. So with this formula, my y is 12. So we need another 12 in the input array, which can be paired with the first element to total 24. As a next step, I need to continue the iteration on the input array and check if 12 exists in it. If we stumble upon a 12, we'll increment our counter. Similarly, we'll apply the same formula and approach on the remaining elements in the array. And as we need the calculated remainders for each element, we'll save it in a table and later on do the lookup for each element. Let's do a couple of runs to understand how will this work in action. Starting with I is equal to 0, the number is 12. After applying the formula, I need another 12 to make it a complete day. Does it exist in the collection? No, it does not. So I will increment our pointer and save the current number in the collection. It is possible that we may have duplicates in the array. And to calculate the correct number of pairs using each of those duplicate elements, we also need to maintain or record the number of count. In this case, we'll save 12 with the value 1. Incrementing my pointer to 1, the value is 12. The expected value of y is also 12. As 12 exists in the collection, we'll take its corresponding value and add it to our counter. The updated value of our count is 1. Now that we completed the iteration for element 2, that is 12, we need to add it to the collection. In this case, because 12 already exists, we'll increment its corresponding value by 1. For the next run, my I is 2 is pointing at 30. So we'll apply the mod operation on it, giving me the output of 6. So my y will be 18. 18 exists. No, it does not. So we'll add this 6 into the array and continue forward. So when we are pointing at 24 and applying the mod operation, the output will be 0, which means it is a complete day in itself. So we can pair it with only those elements which are multiple of 24. We'll check for zeros in the collection. As 0 doesn't exist, we will not increment our counter, add 0 to the collection and increment our pointer for the next run. This time my pointer is pointing at this 24. After applying the mod operation, the output is 0. We'll check if 0 exists. Yes, it does. So we'll take its corresponding value and add it to the counter. So giving us the total of 2. We are done with the iteration and we'll return count as our output. With this solution, our time complexity is reduced to O of n as we are running this iteration only once and there is no nesting, while the space complexity is increased to O of n because we are maintaining this collection. I hope you were able to understand this explanation. Let me show you how we can implement this using C#. Here is the C# solution. I start by initializing a dictionary of type integer and integer to keep tabs on all the remainders and its corresponding counts. Following that, I'm initializing the count variable to record all of the pairs. Then starting a for loop on all the r's in the array. Applying the mod operation to calculate the remainder. If the remainder is 0, it means it is a complete day in itself. So we need to check if the collection that we are maintaining already contains a 0. If it does, then I'm taking its corresponding value and adding it to the count variable. If the remainder is not 0, it will go inside this else condition where we are calculating the total number of hours we need to make it a complete day. So subtracting it from 24. And whatever is this complementary remaining we've got, we are checking if it exists in the collection. If it does, then I'm reading its corresponding value and adding it to the count variable. After this operation, we need to save the remainder into the collection so that we can use it with the next calculation. After the entire for loop is complete, I'm returning the count variable. This code, when submitted on LeetCode, beats nearly 85% of the submissions in terms of runtime and 78% in terms of memory. Thank you for watching this video. I hope you were able to understand this explanation. The link to the code is available in the description below. Feel free to check that out and I will see you in the next one. Thank you.